Hello guys, welcome to my YouTube channel Scholar Tech Studio. In this video, I will teach you step by step how you can do a FEA analysis of a STL file in Ansys Workbench. Let's start. So let's suppose you have any model of STL file. So I have this specimen, but this file is STL file. Okay, so this is the Ansys Workbench. So you will open the Ansys Workbench. I want to do a static structure analysis. So first we have to open the static structure analysis from here. So this is the static structure analysis. You can double click on it, or you can just drag this static structure analysis to project schematic. Okay, so and the next step, we will import the STL file. Right click on it and then use the import option and then select this one. So then you have to specify the STL file. So this is the STL file and then set OK. Now right click on it and then open edit in space claim geometry. So here you can see that the space claim is starting, so we have to wait until this process is completed. Okay, so this is the STL file in space claim. Okay, so what we have to do, we have to right click on this and then here we will find a option convert to solid, and here we will find a option merge faces. So just click on it. Now you can see that our model is converted into 3D. Okay, now we will go to file and then go to save as, and now we will save this file in a specific folder, and file type we have to select step. Okay, and here we can give any specific name like solid file. You can give any specific name and the file type must be step, and then you have to specify the folder, so it's saving at desktop, and then go to save. So now we have converted our STL file to step file and save on desktop. Now we can close this one. Okay, now we will right click on the geometry and now we will replace the geometry. Okay, and this time we will replace this geometry with the step file that we have just created and then said OK. Now our file has updated. So the next step, we need to right click on the model and then go to edit. So our mechanical model is starting, so we have to wait until this process is completed. Okay, so our mechanical system is open and you can see this is our geometry. And now what we have to do, first we have to assign the material. So under the geometry you will click here. So there is only one body, and here you can see that the default material is assigned as structural steel. Okay, so if you want to change the material, you have to add the material in the current project, and then you will find an option here. Okay, by default it has only 3 materials, but if you will add some other material then they will show from here. So in this we just use this structure steel. Okay, and the next step we have to create the mesh. Why we create the step file? Because if you import the STL file then it creates a problem during the mesh. So if we not able to do the meshing, then we are not able to do the static structure analysis. So if you just import the STL file, then the meshing will not be completed. But we converted STL file to step file, and by using the merge faces, now this is a solid file, not a STL file. Okay, just right click on it and then go to generate. So you can see that our mesh is created. You can decrease the size of mesh to get the better results, and from here you can also change the units. So from here you can change the units are in MKS, so I want in millimeter. So now the units are converted into millimeter, and now we can change the size of element size. Let's suppose I make it 1 millimeter. Okay, and then right click on it and then go to generate mesh, and now you can see the mesh is a very structured mesh. Okay, and now we will get the better results. Okay, and the next step we have to apply the boundary condition. In our case, let's suppose that the one face of this specimen is fixed, and we will apply a tensile load at the other end. So we will come here as static structure, right click on it and then go to insert, and here we have to find the fixed support. So this is the fixed support. We will select this face and then go to apply. So we have apply a fixed support as the one end, and now we will apply a tensile load at this end. We will go to the static structure, and here you can see that it's the sign. It means that we have to apply loading or boundary condition. If this condition is not satisfied, then it show like the question marks. Okay, then go to insert and then go to, let's suppose, apply a force. So we have to find the force. So this is the force, and we will select this face. Okay, and then go to apply, and now we have to apply like 10,000 Newton force in y positive direction. So we can apply 10,000. Okay, so now you can see that the direction is outward, but you can also change the direction from here. So here you can see there is the option direction. If you click here, then you will get these two arrow. If you will click here, now you can see that it's the direction is changed, and if I will apply, then you can see that the direction is changed. But in my case, I want to pull this specimen, so I will change the direction and click here. Now you can see that the arrowhead, it's showing that the direction is changed, and now we have to apply. Okay, so now we have successfully applied the loading and boundary condition, and next we need to get the solution. Like what we want to get, we want to get the total deformation, and we also want to get the strain, and we also want to get the stress, and we also want to get the factor of safety. Factor of safety is under the stress tool, and we will use this one. And here you can see that the factor of safety. Now we need to update this. So what we will use, you can just click on the solve. Now the solution is going to completed, and we have to wait until this is completed. Okay, so our solution is completed, and we can put this body in feasible shape direction. And now we will go to the total deformation. So here is our total deformation. You can see that the total deformation is maximum deformation in millimeter is 0.01 millimeter. Okay, similarly we can get the results of strain. Okay, and similarly we can get the result of stress. And the factor of safety, the factor of safety is less than 1, so we can say that this piece is not in stable condition, because the factor of safety is very low. So it must be a greater than 1.5, or and 2 point between that 1.5 and 2 zero point 0.5 depends on the condition, working condition or loading condition. Okay, so now if you want to change the graphics of this specimen from like, if you will go to the results, and here you can see that there is no wireframe. So if you don't want wireframe, so you can use this option. Okay, now we will check. See, now the mesh is disappear, and if you want to see the mesh, so you can use this one. So this will show the just edges, and this will show the elements. Okay, so it's up to you which type of results you want. You can use this one. Okay, and from here you can see that the scale is auto, but if you want to make it true scale, so this is the true scale that will give us the true deformation. Okay, and now you want to export these if you will take the screenshot of this one, then these results are like the graphics are not good. But if you want to get the high quality graphics for your research paper and for your presentation, so you will go to the this option, and here you will find the option image. Okay, and under the image we will select this import to file. Okay, and here we will uncheck this one, and from here we will select the high resolution, and here we will select the image and legends, and here we will select the background as a white background, and here we can font magnification we can select like 4. Okay, and then go to OK, and now we have to specify the folder where we want to save this file. So for that, let's suppose I select desktop, and I give the name like this is deformation, and then save. And now we will go to the desktop, and here, so now you can see the quality of the results. So in this way you can get all the results. So if you will paste this results in your presentation or your research article, so it will looks good. I hope you like my video. Please subscribe my YouTube channel and press the bell icon so that you can get the notification of my upcoming videos.